Hey, are you ready for a deep dive into some seriously cool tech? We're talking lasers in space.
It's just going to be a fun one.
You sent over some research about miniaturized laser communication terminals, and I have to say, the potential here is mind-blowing.
Yeah, it's pretty amazing stuff.
I mean, instead of huge satellite dishes, we could be using these tiny, powerful lasers to beam information between satellites, high-altitude platforms, even airplanes.
And at the speed of light?
It's incredible. I mean, it really makes you think about how much our world relies on fast, reliable communication these days.
It's essential, and not just for things like streaming movies without buffering. We're talking about connecting people in remote areas, revolutionizing how we collect and share data from space. It could have a huge impact on our lives.
Absolutely. And this research from the NICT in Japan really digs into how these mini laser terminals work, and trust me, it's fascinating. They've actually developed two types of terminals, the FX and the ST.
It's a bit like having a supercharged sports car and a nimble city car, each one designed for a different purpose.
So let's start with the FX. It's designed for long-distance, high-bandwidth communication.
Exactly, something like what you'd need for a global internet network, a network of satellites beaming the internet across the globe.
And what's interesting is that even though it's built for these demanding connections, it's still incredibly compact.
Yeah, we're talking a fraction of the size and weight of traditional systems.
Which is a game changer when it comes to space.
Absolutely. Smaller and lighter means it's cheaper and easier to launch, which opens up a ton of possibilities for future missions.
And then we have the ST, which is all about efficiency and flexibility.
This one's perfect when you might not need as much power, but still want that super fast laser communication.
Things like aircraft staying connected over the ocean or smaller satellites sending data back to Earth.
It's like they created a modular system, mix and match laser terminals and modems depending on what the mission needs.
That adaptability is going to be key as this technology evolves.
I think so too.
And believe me, it gets even more interesting when we start talking about the specifics. NICT has packed some really impressive features into these tiny terminals. One of the details that really blew me away was the beam divergence control they've built in.
Oh yeah, that's impressive.
Have you ever used one of those flashlights where you can adjust the beam from wide to narrow?
Sure, yeah.
It's kind of like that, but with a laser beam carrying terabits of data.
That level of control is going to be so important for maintaining a strong signal, especially over those vast distances.
Especially with things like atmospheric conditions.
Exactly.
But what's really remarkable is how they've managed to miniaturize this technology.
Yeah, it's incredible.
Modems the size of a credit card that can handle those kinds of data transfer speeds. It's mind-boggling.
I know, it's pretty wild. And that miniaturization is key.
Absolutely.
Not just because it makes it cheaper to launch these systems into space,
Right.
but it also means we can start using them on much smaller platforms.
Like CubeSats.
Exactly. CubeSats, they're tiny, about the size of a shoebox.
Yeah.
But imagine a fleet of these little guys equipped with laser communication.
Acting as relays for a global internet network.
It's an exciting thought.
And the fact that NICT designed this to be modular, that adds a whole other layer of possibility.
Oh, absolutely. That adaptability is going to be huge.
Imagine being able to customize these communication capabilities for different applications.
Yeah, from scientific research to disaster response to even commercial use. It's like having a toolbox full of high-tech laser components ready to be assembled for whatever we need.
It's incredible, but of course, no technology is without its challenges. Laser communication in space, it faces some hurdles.
That's true.
I mean, one of the biggest is something we deal with here on Earth all the time, right?
Let me guess, weather.
Weather.
Makes sense.
Even though we think of laser beams as these perfectly straight lines, they can be scattered or absorbed by things like clouds and rain.
Even atmospheric dust.
So even with these super fast speeds we're talking about, we have to remember that even lasers have to contend with physics.
It's true. It's a challenge.
And that's exactly why the NICT is putting so much effort into developing these advanced pointing and tracking systems for these terminals.
Right, they have to.
It's like they're building a system that can compensate for these tiny atmospheric disturbances just to keep that laser beam locked on target.
It's remarkable. And they're also exploring different wavelengths of light.
Oh, how so?
Well, some wavelengths are less affected by atmospheric conditions than others.
It's like tuning a radio to find a clearer signal.
That's a great way to put it.
The fact that they're tackling these challenges head-on really shows just how committed they are to making this technology a reality.
It's really impressive to see.
And the really cool thing is this isn't just some, way out there sci-fi concept.
Yeah.
The NICT is taking steps to make this a reality.
It's exciting.
I mean, they've already done experiments beaming data between mountaintops,
Wow.
and they're planning to test these terminals on CubeSats, high-altitude platforms, even integrate them into a large-scale Earth observation constellation.
That's ambitious.
Yeah, and think about it, a network of satellites with these miniaturized laser terminals orbiting the Earth, beaming down data faster than we thought possible.
It's really going to change things.
It makes you wonder, what could we achieve with that kind of speed, that bandwidth?
It's hard to even imagine.
I mean, remember those remote communities we were talking about? The ones that struggle with internet access? Imagine if we could bridge that digital divide, bring high-speed internet to everyone, no matter where they are.
It would be transformative.
Really would, for so many people.
And beyond just connecting people.
Right.
Think about the data for scientists, for researchers.
From Earth observation satellites, telescopes, even planetary probes.
Exactly. And right now, downloading that data takes so long.
But with laser communication.
Near instantaneous.
Imagine what that would mean for things like climate science, disaster response.
Our understanding of the universe.
It's incredible.
It really is.
What I find so inspiring about all this is how this technology could change everything about how we think about communication, about sharing data here on Earth and in space.
It's not just about speed.
Exactly. It's about what we can do with that speed.
The possibilities it unlocks.
And that's what I love about exploring these cutting-edge technologies.
Me too.
It reminds you that we're always pushing the boundaries of what's possible. And that the future, well, it's full of potential.
As long as we keep asking those big questions, keep pushing those boundaries.
Exactly. And who knows, maybe someday soon, we'll all be beaming information around with lasers.
Yeah.
Just like the team at NICT.
It's an exciting time to be thinking about the future of communication.
That's for sure. And on that note, we'll wrap up this deep dive.
Until next time.
Thanks for listening, everyone.